Okay, everybody, hello, welcome. Those of you that know me, welcome back. If you don't, then hello. Um, I like to show that video, particularly because it shows visually everything that we are going to talk about today, what we're going to see, right? The processing, the thermal, the heat treatments we're gonna see, the routing of the flanges, and so on and so forth. A little bit of a visual before we see it now in writing. So a little bit about GSP. We know GSP, we sell GSP, we buy it and we recommend it and we associate it with parts, but we're much more than that. We're a group. GSP Automotive Group worldwide, we are the biggest manufacturer of auto parts in the world, the biggest and largest. This image here on the right, we can actually see the headquarters in Wenzhou. That's our main building, fun fact. Worldwide, we have 5 offices. Each one of these offices are gonna have a warehouse, a distribution warehouse, strategically located, right? So in China, right, in the southern part of China, we have our main offices in Wenzhou. For the European market, we have offices in Cologne, Germany. For North America, right, for the US and Canada, we have offices in South Carolina. It's a little lower down here, South Carolina, and in LA, California, Los Angeles, California. For the Latin America market, right, for Central America, the Caribbean, and South America, we have offices in Miami, Florida, which is where Simone and I work from. In 2015, we constructed our own factory, brand new. So since it's brand new, we get to have the best toys, right? So we have high precision imported machines. Our factory is huge, 300,000 square meters, which is just a number. But here we can actually see it and we can quantify it, right? So right here in the center, where I'm trying to highlight with my mouse, is a truck. Just that is in comparison to the rest of the factory, and we still have this last quadrant to go up, right? So what is the advantages of having your own factory? Well, we get to design it from scratch. The advantages are that we can put everything where it needs to be. Not where it should be, but where it needs to be. The material comes in through here, it's processed here, it's machined and turned here, goes through heat treatment here, quenches here, and goes out for export. Why is that awesome? Because it's a linear, right? Everything's gonna be linear. Instead of having another factory that it's already set up and you have to play with it, you're gonna have something here, then down here, then down here, then down here, and you're gonna get confused, and that's gonna cost time. Our production capacities, these are numbers per month. CV joints, 1.1 million per month. Axles, hubs, shocks, our other lines as well. But our hub assemblies, which is what we're gonna talk about, almost 500,000 parts per month. These are numbers that some factories don't even get to in 6 months, and we do it in 1 month. This is another reason that we had to build our own factory. We don't do these numbers just to say that we make these numbers. No, we have these numbers because this is what we sell. This is what our customers, our market demands. Sorry, almost almost drowned with a drop of water. Apart from the factory that we had constructed, we also made new apartments. These apartments are gonna be for the workers of the said factories, because a lot of these workers come from different parts of China, right? So this way we have them all together. It's a form of community. They feel like family, they can make friends, and you don't get as depressed being away from your friends, your family, and your loved ones, right? So all of these things that we have created for our workers. Again, so since our factory is on the coast, as most factories are, because of logistics, right? It's closer to the ports. Most of our workers, or workers and just in general, come from the center of China and from the northern part of China. So since they're so far away from their families, that's why we created these apartment buildings. All right, getting into the meat of the business here. Wheel hubs and assemblies, what are they? Hubs and bearings. Well, they're the units that help support the weight of the vehicle, right? Most of the weight is gonna fall onto the bearings that are gonna be inside. And also in the second generation and third generations, right, with the splines, we're gonna help transfer some of that power from the engine, transmission, and eventually to the wheels. The bearings allow the wheels to turn with as little resistance as possible. This is due to the precision machining and to the high quality grease that we use. Because if you don't have good materials, you don't have smooth bearings, you don't have a smooth track, you're not going to have a quality part, right? We're also going to have the ABS system, anti-lock braking system, which we're going to talk about in a little bit. And this one, personally, the last one, this is my personal opinion, but it's the most important because it attaches a wheel to the vehicle. In the third generation, as we can see, even in second generation, where the lugs go, right? The lug nuts, that's where the tire is attached. If this part fails, if this wheel hub fails, we're gonna lose a wheel. God forbid that happens, but that is monumental. Right, so the 3 generations of wheel hubs. The first one is very simple in design. The hubs here on the right, it's just a piece of metal, but it's not just any piece of metal. It has to be a quality part. Again, these lug nuts, they cannot fail. So they themselves have to be quality. Where they're attached, that material, we do a heat quenching, a heat treatment process to make sure that that part won't fail. The inside of the splines, we also give it a heat treatment so that when it's in contact with the CV joint, right, which is part of the CV axle, so they don't strip, because if they strip, then we don't have a part, and what's the point of that? Second generation hubs, sorry. Second generation hubs, we're gonna get a little more fancy, we're gonna get a little more advanced. Why? As you notice here on the right-hand side, we're gonna integrate the first generation hub with the first generation bearing. We're gonna create one part. By creating one part, we're gonna lighten the weight of the actual piece. Great, right? So we have the bearings that go inside of the part, and we're gonna reduce the mounting weight. The mounting weight, we want our vehicle to be as light as possible so that our engine and our transmission works with the least resistance possible. This is where you get your optimum miles per gallon, where your engine has a longer life, a longer service life, because it's not working as hard. And third generation, this is the generation of hubs that we are getting into. These are much more complex, as we can see in the images. We're gonna integrate everything, even straight to the steering knuckle, right? So this upper flange is gonna go straight into the steering knuckle. We're not gonna have to mount it to another piece and then to another piece. The bearings are gonna be integrated. These parts can be opened. If you do, it's gonna be very, very, very difficult. First of all, to press it back together, and second of all, to get it right. On this top part, right? If we remove that top flange, when we go to press it again, we could overpress it, we could underpress it, and we can press it skewed, right? Instead of being completely parallel, it might be at an angle. Even if it's 1 degree off, that's gonna play a huge part in the life of the part and in its performance. So before I mentioned ABS, what is ABS? ABS is anti-lock braking system. It is a measure to prevent your car from skidding. When our cars skid, we have no control over the car. It's gonna go in the same line of momentum. You're gonna have no ability to control it. The ABS is gonna prevent your wheels from locking up by pulsating the brakes, right? So very rapidly, the brake calipers are gonna start to try to lock the wheel to get the car to finally stop. In this diagram, we can see that in action, right? So on the top, in the gray, we have your braking line. This is where the brake is applied, and we have a cone, we have an obstacle in the road. It could be a cone, it could be a tree, it could be a soccer ball, right? It could be anything. We can see that the wheels are turned, so the driver tried to avoid it, but because his wheels locked up, the car went in the same line of momentum and eventually collided. When we have ABS, as we can see on the bottom, as the brakes apply its pressure slowly, we allow that wheel to turn and we still have control of that vehicle. Now, why is this important? Because our cars are gonna start to have it. The ones that have it, wonderful. But newer model cars from 2013 and up, they are mandated to have ABS. So this is a new technology that we have to start getting into. In the first generation, it's gonna be magnetic. We're gonna find it on the bearings, not the hub, because obviously not the hubs, but the bearings, right? On the outer, on one of the sides, not both, just one, we're gonna have a magnetic strip. And this magnetic strip has to be facing outward, not into the flange, but outward. Why? Because we're gonna have a sensor as we can see on the image on the right, by the brownish, orangish, gray sensor that we can see. That's gonna be looking for a magnetic signal. It's gonna send pulses and it's gonna expect to receive some back. If we put the bearing backwards, right, into the hub, it's never gonna find that signal. It's gonna throw an error to the computer, and the dashboard is gonna give us that ABS triangle. In the second generation, it's gonna be a little easier, right? Why? Because it's gonna be one of two ways, either physical, by ring or by a window, which we're gonna see as soon as we take it off, or a customer brings it into the shop and puts it on the counter and says, I need the same one, we can tell. It's gonna be a little bit more difficult with the magnetic one, but the good thing is that there's no way to install it incorrectly. Same concept, we're gonna have a sensor that's gonna be looking for either the magnetic pulse or the physical ABS ring or window ring, right? So this one is a little more easier, a little easier, more easier, a little easier, easier. Third generation is gonna be the easiest. It's either gonna have it or it's not gonna have it. It's gonna be apparent. When you take it out of the car, when you dismount it, you're gonna see it. There's gonna be either a cable, as we can see on the upper left, or there's gonna be a sensor plug, right? It's gonna go into it. So in order to take off that part, you're gonna have to unclip it. That's the easiest one to see. But the ABS for these third generations are also gonna control something called the traction control system. This is more evident in four-wheel drive cars. Why? Because the traction control does just that, controls the traction of the vehicle. When the computer senses that the wheel is slipping, right, we're accelerating and we're not going anywhere, the computer's gonna tell the wheel, hey, you're getting too much power, cut it out, and the wheel will stop turning. This actually happened in my car. I drove a Hyundai i30, it's a manual car, and in my previous car, I love to burn rubber, right? You put it in first gear, you rev it up to 4,000, you pop the clutch, a lot of smoke. But I couldn't do it in this new car. I didn't realize that it has traction control system. You can take it off, but it's annoying. And then if you forget to put it back on, it affects your driving and your handling. So obviously don't do it. But it's pretty cool to actually see it in action as well. The cable, the sensor, it's gonna communicate back to the computer, right? To our computer. And in the event of a lockup, the computer through the ABS, either the ABS cable or from the sensor, it's gonna communicate to the brake caliper, hey, we need to stop now. Don't apply pressure all at once. We're gonna slowly start applying pressure to get the car to stop. Our ABS machines, we actually bought new machines because this was something that we were outsourcing and we didn't like it. So we bought our own machines, right? So now we can control this. One by one, these hubs are tested. So these are the hubs that were already tested. On the left-hand side, we have the ones that have not been tested. They are plugged into a machine. The machine runs code. It'll send the signal and it'll expect a signal back. This screen on the outer edge has like an LED and it'll turn one of two colors, green. If it turns green, boom, it goes into this cart. If it turns red, that part is thrown out to a red bin that's on the floor. It means that there's something wrong with the ABS. This is to make sure that all of our parts work correctly. Again, this is the same machine, but for the magnetic ring. This is for the sensor clips and the sensor cables, and this one's for the magnetic ring. The heat treatment that we do on these parts, why do we do them? To reinforce key points. The key points on a wheel hub are going to be the track where the bearings run. We need that road surface, right? Where the bearings are running, that track to be reinforced. As we said before, these bearings are gonna support most of the weight of the vehicle. Over time, those bearings could create an additional track, right? Like an indentation. Once you have an indentation, you're gonna lose your tolerance. With that tolerance, you're gonna have play between the between the bearing and the actual part, and that's when you have your knocks. Knocks after time in a mechanical system is going to lead to failure. So here in the 3 generations, well, the first one, yeah, and on all 3 generations, we can see the heat treatment. In the first generation hub, it's going to be down the spline. In the second generation, we can see it on the bottom where the bearings are. If it's double track bearing, we're going to see 1 and then 2. And then in third generation, which most third generation are double row bearings, you're gonna see 2 tracks of the heat treatment and where it was. The heat treatment is gonna leave a mark because we are going to alter the characteristics of the metal. We're gonna harden it, we're gonna crystallize it, and it's going to change color. Some precautions with these bearings: use as OE intended. What does this mean? If there's a car that was designed for 7 passengers and we put 15 passengers on it and the bearing fails, that's not how the manufacturer intended, right? These parts are OE replacements. They're not performance, they're not ultra endurance, they're OE replacements. Used as an original equipment manufacturer intended that part and that vehicle to be used. Avoiding shocks to the system. This is by, for example, if there's a speed bump in the road, don't take it full force. If there's a hole in the road, don't take it full force. Slowly, yes, as we're supposed to drive, right? As soon as we have shocks to a system, that shock is gonna permeate and it's gonna find the weakest link in our suspension system, and that's where our energy is going to explode or be released, and the weakest part is the one that's going to suffer. Do not submerge. Submerging, yes, if it's raining, yes, if there's a puddle on the road, that's fine. But we can't cross a river and we can't park it in the river. Our hubs are all sealed, right? We have the special seals that go around both sides to make sure that nothing goes in or comes out, to keep our grease perfectly exactly where it is and to keep all dirt and debris outside of the bearings. But if it's submerged, if it's left underwater, if it goes, as again, if it goes across a river, a small stream, or in a puddle, fine. But don't park it such that the hub or the bearing will be underwater. And lastly, install correctly. Installing correctly means applying the correct torque measures, not taking it apart as we mentioned before and trying to put it again. When we press the Gen 1 bearing into the Gen 1 hub, make sure that it's even, that it's not at a slight angle, that it's not askew, and connecting the ABS. If our car requires ABS, use it. So now a little bit about GSP. Who is GSP and why do we use GSP? Our quality. The quality that we have at GSP is top notch. Again, we're #1 in the world in aftermarket, and our quality has to match that, right? We are experienced in manufacturing. In manufacturing, we've been around since 1985. That's 35 years, if my math is correct. And this year we're celebrating that, which we should see or should have seen. I don't know if it's still gonna go on, but Automech in Shanghai. And our certificates are ISO 16949 and ISO 14001. The 14001 is for I forgot in English how you say it, to make sure that everything is delivered on time, right? So if a customer orders 5 containers, that he actually got 5, that we didn't just send 3, because some companies will do that, right? They'll say, hey, yeah, we'll quote you and we're only gonna send you 3 containers instead of 5 because we couldn't complete your order. That was the word I was missing. And the ISO 16949 is a certificate that certifies that that factory and that specific line is good enough to be sold as OE. And we in fact sell some of these parts OE, right? So we'll make these parts and we'll send them out to the manufacturing plants to be installed in the car. So when they come off the line, a brand new car, it'll have a GSP part on it. Oh, 35, my math was correct. 35 years in the auto part business. The materials that we use, oh yeah, our base materials, we import these materials and we make sure that they're the best. Why? Because we need a part that's going to be the best as well. Our state-of-the-art machinery, the ones that we buy all the time to replace the older ones, the brand new factory that we built, we have the brand new machinery on it. And machinery like the ABS machine that we talked about, which was a process that we used to outsource, but now we do it in-house. And again, our OE spec products. Robot welding. This is for our other lines that do require welding, like our suspension, right? Our control arms will use robots. Our shock absorbers will use robots for spot welding. And something cool about these robots and that they're welding robots, and I included on here because We have a special team that controls these robots or that overlooks these robots, right? When a robot grabs a part and it'll weld, either a spot weld or a continuous arc weld, if I were to check that weld, right, I grab the part and I'm like, oh, it's a good weld, I guess. Yeah, I don't know about welding. But the people that handle these machines are welders. So they're able to look at a part and look at the weld and say, yeah, that's a good weld. Or say, no, that spot weld, I'm not feeling it. There's a small gap, there's this or that. And either they'll go and personally fix the weld, or if they can't fix it, they'll put it in the red bin for that part to be reworked from zero. Product development, when we go to develop a new part, right, these are all the steps that we have to take into consideration. This also falls under my supervision, so all of this has to be in order with the team in China, with the team from Latin America and the customer. And there's a lot of redundancies, right? So if the part is okay, or if the part is not okay, right, we'll go back, not to the previous, but to the previous one. Why? Because of redundancy. Okay, not okay, it'll go all the way back to evaluation, it'll continue, and eventually we have a new part. Usually it's about 60 days from the time we receive a part to the time it's shipped out for a new product to be developed. Our product testing facilities, as you can tell, everything is pretty clean now. Everything is very clean. Here we can see the reflection. Why is this important? In this control arm, they're measuring the inner diameter, the outer diameter, and to make sure that the circle is a circle. Sorry, to make sure that the circle is a circle. If the room isn't clean and there are dust particles, rocks, sand, even just a grain of sand will throw the tolerance off. And this will make, and if the tolerance is off, then the whole part and the whole batch will be scrapped. The service, our service, in every office that we have, right, in all 5 offices, we have people that speak the native language or the language around that area. Why? So that when there's a problem, we can go and be there in person. So when there's an issue in Guyana, we were there. We went there, we saw everybody. In our office here in Miami, we speak Spanish, English, and Portuguese. So we're able to communicate across the whole territory, right? If there's an issue, we can communicate that issue back in English to our factory. The factory, that's our default language, English. Where is GSP going? Well, we have to find a way to still be number 1, right? Because we're the biggest, we're the best. So our first to market, what does that mean? When a new car comes out, GSP is already trying to get that part, right? So that way, in a couple of years, when those cars are out of the warranty, right, from the dealership, we are there. In the year 2019, we purchased over 500 OE samples. We all work with parts and we all know dealerships and we know that these samples are not cheap, but we need these OE samples so that we can have the optimum piece. And strong technological support. In Europe, TechDoc is the biggest. It's the biggest centralized cataloging system, and we are a partner of that. WHI in North America and worldwide for TMOT. This is used for the sharing of information. Product optimization. So this part's pretty cool. On the left-hand side, we have an OE part, right? This is how it is, and this is how it's sold in the market. And on the right-hand side is what GSP did with it. Our research and development team got a hold of this part and said, how can we make this part better? So this is what we came up with. We draw it on 3D, we draw it on AutoCAD, or any computer-aided design software, and we play with it, right? Where the studs are, where the lug nuts are, it's the same. If anything, it's a little bit reinforced, but this extra material is cut out. When we can cut out extra material, the piece is lighter, it's cheaper to produce, which then means it's cheaper for the final consumer. When we did this part, when we manufactured this part, there was actually a car manufacturer in China that said, oh, GSP, that's a very nice part. It actually makes the car a little lighter, even though it's just this. Imagine if every part just had a little bit of weight off, right? So we supply this part OE to a manufacturer. Same thing with this wheel hub. This is the nut for the CV joint, the outer CV joint, the end of the CV axle. As you can tell, that nut is sitting on the track of the bearings, right? If we open nut, we're gonna start to lift the sides here of the seal. As soon as we lift that seal, that creates a gap. We break that seal, and that's when water, dirt, and any debris, can get into the part and ruin it. So what did GSP do? We extended the spline shaft. We made it a little higher, and this outer lip is it's connected to this bottom flange. What does that do? When this nut rests on this, you can put as much torque as you want. You can put all the force you want. It's never gonna touch my bearings. If it doesn't touch my bearings, you're not able to break that seal, you're not able to lift it, you're not able to manipulate it. You have a part that lasts a little longer. Again, we got a hold of this, said, hey, GSP, that's a great idea. Send me all your specs for it, send me all the testing that you did for it. They do their own testing, we do our testing, we come to an agreement, and now this part is used OE off the line on some manufacturing parts. For product development, this also goes back in hand. We have developed a forum where we're able to chat with each other across different countries to see what we need. If there's a part that doesn't have fitment, or if it's cross fitment, right? Some different cars under the same brand will fit each other. Not everyone knows that, but obviously the mechanics and the technical people that are with it every day do know that. So we're able to share that information and expand our coverage. This goes in hand with the market research. The market research is also done when we're on the ground, right? When we travel, we go, we meet with people, and we see what's going on. Also, another line that GSP got into is for ATVs, right? So we have these axles. It's not a wheel hub, not yet. We're getting there slowly. But right now we have the axles, right? So we're able to develop these. We're doing fantastic in them. The North America team has had a huge success with it. So now we're expanding it to our other markets. ATVs are like side by sides. I don't know what they're called in each market. I'm very sorry, but there's one person, there's two person, there's up to 6 people that can ride these. In the US, they're used more for fun, but I know, for example, in Colombia, where I'm from, we use these a lot in the farms to get around. Instead of using a motorcycle, if we need to haul something, we just grab on one of these, for example, and we're able to go pick up what we need and come back, and you just leave them anywhere. And since they're exposed to the elements, all these parts are always breaking. You always have to jerry-rigging something. So here we have these parts now. So yeah, guys, I want to thank everybody for attending. If you guys have any questions, ask Simone, and we'll take care of them. Here are some of our links for y'all to go follow us. And Simone.
Yes, I'm here. We do have some questions. Let me read them for you. Yeah, we get asked a lot. How often should the revision service be made?
Well, that's a good question. How often should hubs be looked at or serviced? My suggestion is to do it every time you do an oil change, right? Because in oil change you do pretty frequently, every 5,000 miles, 6,000 miles. I do it every 5,000, even though I think it should be more. But so when you do the oil change, since the car is already lifted, just check the components, check everything in the suspension, check your CV boots, check your bearings, move the wheel to see if there's any play in the system, right? Spin it to make sure that it's smooth. Check your control arms, check your bushings, grab everything and move it to make sure that all your ball joints are exactly how they should be.
Okay, and Roger, that one I'm gonna read because I just answered him. Roger from Suriname. Hi, Roger. He asked if every hub gets tested at GSP, and yeah, I think it's very nice to ask. What I explained to him is that we have a very stable production, and we use CNC machines, which are high precision machines. But regardless, we do maintain to maintain our quality control, we do run sampling tests per batch per item. So that's why when you get the products in your hands, you can see how flawless it is. With there are no scrapes, there are no scratches. We have the protective oil. We have, it's a clean product. It's a polished product, and you can see that. We do have another question. What are the signs of a faulty wheel hub? When do we know that it needs to be repaired or replaced?
The signs of a faulty wheel hub, that's a good question. Usually when we hear squeaking while we're driving, when we turn, we may hear either squeaking or clicking, although when turning and the clicking, that's usually for CV joints, but it could also be. So if you hear it, just make sure to check the wheel hub and the CV joint. And one of the telltale signs is when you're driving, when you're driving in a straight line on a smooth road, of course, you feel a vibration in the steering. And when you feel that vibration, it could be at the hub isn't rolling perfectly. It could be at an imbalance. Also, another sign is when you have uneven wear on your tires. That could be also for the shock absorber, but check your wheels. If your wheels have uneven wear, that could also be a sign.
Okay. Let me see. This one is, yeah. Is it advisable to increase the grease in the hubs? Should we
add more?
Add more grease to the hubs. Especially in Bolivia, I think it's a little bit of cultural thing. They like to add, for example, in CV joints, they like to add double grease in the CV joints and the bolts. And they've been asking us to sell separately the grease for hubs. And I said, well, what is the purpose? There's no need.
No, so for wheel hubs, there's no need. First of all, they already come sealed from the factory, as I mentioned before. And to open it and then to put it back together, it's gonna be a hassle. If anything, it'll even ruin the part, but no, to not add more grease. And talking about the grease, don't mix greases. This goes for all the products, even I know for first generation wheel bearings, those can be opened, especially in other brands, but don't mix the greases. If you like a particular brand of grease, stick to that grease. Don't try to clean it out. Don't try to mix greases, because each grease has its own chemical composition. And when you try to play with those chemical compositions, you're gonna mess something up. You're gonna have a chemical reaction. You're gonna create lumps, like little rocks. And that's what you're trying to avoid in the first place. So yeah, but to add grease to wheel hubs, no, there's absolutely no need.
Okay, let's see. Okay, we have quite a few questions. What we're gonna do is we're gonna answer them together with our team, and then we're gonna submit all questions and answers to everyone who joined today. Thank you, Andres, again for a great presentation. I do hope everyone was able to learn a bit more about this line from GSP, the wheel hubs and bearings.